Hello everyone. Welcome to the mini lecture on advanced manufacturing technologies for welded structures. I'm Huang Bin. Today we will learn the relevant content of robot welding programming together. It is a very practical technique that is widely used in modern manufacturing. Through robot welding programming, we can achieve efficient and precise welding operations, improving production efficiency and product quality. I hope that through this lesson, everyone can master the basic methods and skills of robot welding programming. We first start with welded structure analysis. The welded structure is the foundation of the whole welding programming. We need to read the product structure diagram carefully, which is a critical step. The figure shows a local structure diagram of bucket rod for 906 excavator. By combining the basic knowledge of drafting and welding, we can build 3D drawings of assemblies and parts. This step can help us better understand the structural characteristics of welded objects. Next, let's look at the analysis of the bucket rod structure. As shown in figure A, this is the assembly structure, while figure B shows the part disassembly. Through this disassembly, we can clearly see the position and relations of each parts, which is crucial for subsequent welding process analysis. Let's start the robot welding process analysis. The task description is the welding of the support and the main plate, which requires automatic welding by robot. The weld location and welding requirements are shown in the figure. The focus of this part is to clarify the specific requirements of the welding task, preparing it for subsequent process analysis and programming. In process analysis, we must first analyze the welding characteristics of the workpiece. Understanding the material, structure, and welding requirements of the workpiece is the prerequisite to ensure welding quality. Meanwhile, we also need to analyze the key points and difficulties of test piece welding. These analyses will help us formulate a proper welding process. Next, we draw up the specific welding process. It includes the combination of robot programming with the welding process, as well as the specific steps of robot programming and the welding operation. According to the specified process, we need to prepare the corresponding tools and equipment to ensure the smooth progress of welding operation. During the robot welding, we may face some key points and difficulties. For example, problems such as assembly dimension error, wrong edge, and low assembly efficiency may occur during the test piece assembly. In view of these problems, we can solve them by measuring tools and formulating a reasonable assembly welding sequence. But joint of root pass welding is also a difficult point. There may be problems such as insufficient welding at both ends and burning through of the root pass. The methods to solve these problems include optimizing the programming position setting of robot welding and welding gun posture, formulating a reasonable welding process, and adjusting the arc strike and termination points. The problem of poor weld overlap is easy to occur at the weld intersection. We can solve the problem by optimizing the programming position setting of robot welding and welding gun posture, and formulating a reasonable welding process. Problems like undercut and poor weld continuity may occur in the flat fillet weld of the bottom plate connection. These problems can also be solved by optimizing the programming position setting of robot welding and the welding gun posture, and formulating a reasonable welding process. During arc strike and termination welding and two-plate welding, problems such as unstable welding position and easy crooked welding at the head and tail may occur. Optimizing the programming position setting of robot welding and welding gun posture is an effective way to solve these problems. Next, let's start the robot welding process analysis. First, analyze the weldability of test piece. The material of the test piece is Q235, which has good weldability. In terms of structural weldability, the test piece adopts butt joint plus fillet joint, flat welding plus vertical welding. This structural design is reasonable, and the accessibility of the welding gun is good during robot welding. Let's look at the equipment performance analysis. The robot used is Xinjiang Robot QJRH41A with a load of 4 kg and a working radius of 1410.5 mm. The welding power supply adopts outside power source. The performance of these devices directly affects welding quality and efficiency. In terms of equipment inspection, we need to check and confirm whether the connection, communication, and operation of the robot body, arc welding power supply, gun cleaning and wire cutting system and other equipment are normal. Meanwhile, it is also necessary to verify the tool center point, TCP, of the robot system to ensure the accuracy of equipment operation. Welding material inspection is equally important. The gas is 80% AR plus 20% CO2, and the welding wire is ER506 from Tianjin Jinxiao, with a diameter of 1.2. The quality of these materials directly affect the welding effectiveness. Determining the welding sequence is a critical step in robot welding. In order to control the influence of welding heat input on weld quality and deformation of test piece structure, and improve welding efficiency, we need to formulate a reasonable welding sequence and direction, as shown in the figure. Specifically, welding the front support to the upper and lower wing plates is the first step, and welding the rear support to the lower wing plate and the rear ceiling plate is the second step. This sequence can effectively reduce welding deformation and improve welding quality. Next, welding the front and middle support with the left and right webs is the third step. This step requires attention to the weld symmetry and welding sequence to ensure the stability of the welded structure. Welding the rear support with the left and right webs is the fourth step. This step also needs to be carried out strictly in accordance with the welding sequence, ensuring the quality of the weld and structural integrity. Welding the lower wing plate with the left and right webs is the fifth step. In this step, we need to pay attention to the control of welding parameters to avoid welding defects such as undercut. Welding the outer sides of the left and right upper support plates with the upper wing plate is the sixth step. This step requires attention to the weld direction and symmetry to ensure the stability and aesthetics of the welded structure. Welding the front and middle support with the left and right webs is the seventh step. This step needs to be carried out strictly in accordance with the welding process, ensuring the quality of the weld and structural integrity. Welding the rear ceiling plate with the left and right webs is the eighth step. In this step, we need to pay attention to the control of welding parameters to avoid welding defects and ensure the quality of welded structure. Welding the front and middle support with the left and right webs is the ninth step. In this step, we need to pay attention to the weld sequence and symmetry to ensure the stability of the welded structure. Technical requirements for support robot welding cover: weld bead cleaning and anti-splash agent coating, daily inspection of welding gun TCP point, weld directional symmetry control and confirmation of robot safety position. These requirements are important guarantees to ensure welding quality and safety. The key points of welding programming of support robot include welding position of two-plate saddle joint, adjustment of welding gun angle and arc centering position, setting of welding current, etc. These points can help us better complete welding programming. The programming point of the arc strike and termination joint of the two-plate weld is to prevent unfused, pits or unevenness defects. The welding method can be arc sensing teaching or arc trajectory teaching, and the specific operation needs to be selected according to the actual situation. Finally, let's look at the specific operation of teaching programming. Teaching programming is the core link of robot welding programming. Through reasonable teaching point setting and welding program writing, efficient and accurate welding operation can be realized. The writing of welding program needs to be carried out according to the requirements of welding process to ensure welding quality and efficiency. That's all about today's mini lecture. I hope that through this lesson, you can gain a deeper understanding of robot welding programming. Thank you for listening.